Welcome back to The Explainer. Today, we are doing something a little bit different, and honestly, a whole lot more terrifying. We're taking a completely immersive, point-of-view spacewalk straight into the cosmic abyss. We're going to explore what are easily the most mind-blowing, brutal, and utterly fascinating objects in the entire universe. I want you to go ahead and forget everything you think you know about how space and time are supposed to work, because today, we are heading straight toward the ultimate point of no return. Seriously, strap in for this one.
So I want you to ask yourself a question, and it's a pretty chilling one. What happens when reality simply breaks? Because when we talk about black holes, that is exactly what we are dealing with. We are heading to a place where the known laws of physics, the very rules that govern how absolutely everything in our daily lives operates, completely and totally unravel. For decades, scientists actually dismissed these cosmic anomalies. They thought they were just mere mathematical curiosities, just a bizarre glitch in an equation. Even Albert Einstein himself initially refused to believe that something like this could actually exist in nature. But they do exist. They're out there right now, silently shaping whole galaxies.
All right, before we take the plunge, we absolutely need to define what it is we are actually looking at. First off, a black hole is not an actual hole in the traditional sense. It's not some empty void, and it's definitely not a physical tunnel you can just touch or fly right through. It is a region of space-time that has been warped so incredibly intensely by gravity that absolutely nothing, not even light itself, can escape its grip. So how do they get here? Well, they are born from massive cosmic death, specifically the violent supernova death of incredibly huge stars. When these giant stars finally run out of nuclear fuel, their core suddenly implodes. It crushes trillions of tons of matter into a state so ridiculously dense that its gravitational pull becomes practically infinite. The very fabric of space just curves inward on itself like a bottomless pit.
To truly wrap our heads around this, we are going to simulate a free fall straight into one. We'll be passing through 4 distinct zones on our descent. First up, we'll navigate the fiery, swirling chaos of the accretion disk. Next, we'll hit the completely mind-bending optical illusions of the photon sphere. Then, we are going to cross that ultimate boundary, the event horizon. And finally, assuming we survive the journey down, we will meet our ultimate fate right at the singularity.
Okay, Phase 1, approaching the black hole. Now, from a distance, you might think a black hole is just completely invisible, right? But as we get closer, the visual chaos is literally blinding. And seeing it up close actually corrects a pretty common misconception. We usually picture that glowing ring around a black hole as being this fiery orange, but if you were looking at it in visible light, it's actually a blinding, intense blue. This massive glowing ring is called the accretion disk. It's basically a superheated cosmic tornado made of gas, dust, and completely shredded stars, and it's all spiraling inward at almost the speed of light. Now you'll notice something weird. One side of the disk looks significantly brighter and bluer than the other side. Why is that? Well, it all comes down to the Doppler effect. Because this plasma is orbiting so incredibly fast, the side that's spinning toward us actually compresses the light waves. It stacks them up, which gives them higher energy, making them bluer and fiercely bright. But on the receding side, the side spinning away from us, those light waves are being dragged and stretched out, which makes that side look much dimmer and a lot redder.
As our ship drifts even closer, the view outside the window gets even stranger. Thanks to a wild phenomenon called gravitational lensing, the gravity right here is so overwhelmingly intense that it essentially acts like a giant cosmic funhouse mirror. The light from background galaxies that are millions of light years behind the black hole, actually gets pulled and contorted around it. The black hole is literally bending the physical path of light, smearing those distant galaxies into these weird glowing distorted rings all around its outer edges.
And then, suddenly, we hit our next major milestone. We are now hovering right over the sheer edge of darkness. We've reached the photon sphere. The gravity in this specific spot is perfectly balanced. It's strong enough to capture light, but not quite strong enough to actually swallow it whole just yet. Because of this, light particles, or photons, are literally trapped in a permanent circular orbit around the black hole. Think about what that actually means for a second. If you were to stop your ship right here, float out, and look straight ahead, the light reflecting off the back of your own head would travel in a complete circle all the way around the black hole and come right back into your own eyes. You would literally be looking at the back of your own head.
All right, Phase 2, crossing the event horizon.
We have officially arrived at the terrifying boundary of no return, and here is where the passage of time itself basically loses its mind. It really becomes a tale of 2 entirely different perspectives. Let's say you have friends back on Earth, the outside observers, watching your ship fall toward the event horizon through a massive telescope. To them, your descent actually appears to slow down. The extreme gravity is severely warping time, which is a phenomenon called gravitational time dilation. To your friends, the clock on your ship is ticking slower and slower. You appear to just freeze completely right at the edge. Your image gets dimmer, redder, and then you just sort of fade into nothingness. They will never actually see you cross the threshold. But for you, the falling astronaut, you don't notice anything unusual at all. Your heartbeat, your ticking clock, your basic perception of reality, it all feels completely and totally normal to you as you plunge right through that dark boundary.
Let's take a second to clarify exactly what it is you just crossed. The event horizon is the ultimate point of no return. But it is so vital to grasp that you didn't hit a physical wall. There is no hard surface. You wouldn't even feel a bump. Instead, this is simply the exact mathematical threshold where the escape velocity required to pull away from the black hole finally exceeds the speed of light. And since absolutely nothing in the universe can travel faster than light, nothing can ever leave. But honestly, it's even weirder than that. The geometry of space itself has been twisted so severely that outward literally no longer exists as a physical direction. Every single possible path you could conceivably choose to travel on now leads exclusively deeper inside.
Moving into Phase 3, plunging toward the singularity.
So you know how gravity normally feels like a uniform pull on your whole body? Well, in here, it is a massive, severe gradient. As you fall closer and closer to the exact center, the gravitational pull on your feet becomes significantly, violently stronger than the pull on your head. These extreme tidal forces begin to physically stretch you out. Scientists have actually given this a brilliantly grim nickname: spaghettification. Your body, your spaceship, and eventually the very atoms that make you up are stretched from head to toe into a long, incredibly thin stream. You are literally flayed apart, layer by atomic layer.
And while your physical form is dealing with that absolute nightmare, your reality is being totally inverted. This is, for my money, the ultimate mind-bender of the black hole's interior. Think about our normal lives. We can move freely through space, left, right, up, down, but we are helplessly dragged forward through time. You can't stop tomorrow from coming, right? Well, inside a black hole, those roles literally swap. Space and time blur and trade places. Moving toward the center of the black hole is no longer just a direction in space. It is your literal future. You can no more avoid hitting the center than you can avoid the passage of time itself. Falling inward isn't just a physical movement anymore. It becomes absolutely inevitable.
Which finally brings us to the absolute end of the line, the singularity. All the massive weight of that original dead star, plus absolutely everything else that has ever swallowed over billions of years, is compressed into a single infinitesimally small point. We're talking about infinite density. We're talking about zero volume. This isn't just an extreme environment. It is the exact spot where our entire understanding of reality completely collapses. Both general relativity and quantum mechanics simply fail to work here. The math just spits out infinities. It is mathematically undefined. Whatever is actually happening at this very center is, without a doubt, the greatest unsolved mystery in all of physics.
Okay, Phase 4, the information paradox. Let's zoom way out from our doomed little spacewalk for a minute and look at the quantum aftermath of all this. This introduces something called the no-hair theorem. Think about how much information it takes to describe just an ordinary everyday object. To properly describe the craters on our moon, you'd need millions of data points. To describe a human face, it takes an almost infinite amount of data. And yet, when a giant star collapses, or when an entire encyclopedia gets thrown into a black hole, all that incredibly complex information seems to just vanish. Despite swallowing billions of gigabytes of cosmic data over its lifetime, a black hole is perfectly, entirely defined by just 3 simple numbers: its mass, its spin, and its electric charge. That's it. It has no hair, meaning no other distinguishing features whatsoever.
To really put this absurdity into perspective, let's talk about the monster sitting right in the center of our very own Milky Way galaxy. It's a supermassive black hole called Sagittarius A star. This absolute beast contains the mass of 4 million of our suns. 4 million! And yet, despite being formed over billions of years, slowly built up from countless dead stars, massive clouds of gas, and swallowed planets, its entire identity is completely stripped down. It is entirely defined by just those 3 tiny numbers. But here is where we run into the ultimate physicist's nightmare. You see, according to the fundamental laws of quantum mechanics, information cannot be destroyed, ever.
Everything about a physical system, the specific particles, their unique quantum states, must be preserved somewhere in the universe in some form. But black holes seem to just aggressively destroy it. So, if quantum laws say information has to live forever, but relativity says a black hole crushes it into absolute nothingness, who is right? It's a massive contradiction. Physics, as we know it, is totally broken right here.
So how do we resolve this huge paradox? Well, scientists have two absolutely wild theories. First, there's the holographic principle. This idea suggests that the information actually isn't lost inside the black hole at all. Instead, as an object falls in, all its 3D information is perfectly smeared and permanently encoded onto the 2D surface of the event horizon, kind of like a hologram, where the outer boundary actually holds all the data of the interior. The second theory is Hawking radiation, famously discovered by Stephen Hawking. He figured out that because of weird quantum fluctuations near the horizon, black holes aren't totally black. They actually leak tiny amounts of radiation. Over trillions upon trillions of years, a black hole will slowly shrink and eventually evaporate away completely. But the lingering question remains. When it finally vanishes, does that leaked radiation carry all that encoded information back out into the universe? Or is it truly finally gone forever? We still honestly don't know.
And that leads us perfectly into Phase 5. Are we the inside?
I want to shift gears here to close out with a deeply provocative, scale-flipping theory about our own reality. What if we had been looking at this entire thing backwards? Consider what physicists call the cosmic coincidence. First off, if you were to take the entire mass of our observable universe and you calculate exactly how big a black hole that specific amount of mass would create, the resulting event horizon is exactly the size of our universe's cosmic horizon. Exactly. Second, recent astronomical studies show that roughly 2/3 of the spiral galaxies we observe are all rotating in the exact same direction. Now, in a totally random universe that just ballooned out from a uniform Big Bang, spins should be 50-50. A net rotation, a net angular momentum, really shouldn't exist, unless… Well, remember earlier how we said angular momentum, or spin, is one of the only pieces of information that actually survives the fall into a black hole. Just like an ice skater pulling her arms in to spin faster, if an enormous gas cloud from some parent universe collapsed into a spinning black hole, the new interior reality created inside it would retain that original spin.
So the crucial point we are left to ponder is simply this. When the extreme math of Einstein's relativity is pushed right through the singularity, some equations suggest that a brand new spacetime might actually open up on the other side. An entire new universe unfolds. Does that mean our Big Bang was just the perspective from the inside of a collapsing star in another, much older universe? Do black holes not just destroy but actually create? Are we literally living inside a black hole right now? It is a profound, truly breathtaking thought that forces us to question the very fabric of our own reality. And honestly, that is exactly what makes the study of these cosmic leviathans so endlessly fascinating. Keep looking up and keep questioning everything.